Last video, we saw types of control valves based on the shape of the valve body. We saw two categories in this, that is sliding stem type of control valves and rotary valves. Under sliding stem, we studied globe valve. In globe valve, we studied single-seated, double-seated, three-way valves. Also, we saw split body and angle valve. Then we saw diaphragm valve. Now, these valves are sliding stem. That means the valve closes and opens due to vertical movement of the stem. These types of valves are suitable for high pressure drop applications. Now, as the fluid passes through the control valve, there is a pressure drop across the plug. Since the movement of the valve stem is vertical, in case of sliding stem, the pressure drop that is created across the plug does not affect the movement of the valve stem. In case of rotary valve, the valve opens and closes due to circular or rotary motion of the actuator stem or valve stem. As the liquid passes through rotary valves, it causes pressure drop, and that pressure drop tends to move the valve stem in a circular fashion, but in the opposite direction to the direction in which the actuator is moving it. So that is why rotary valves are not suitable for high pressure drop applications. Now let us see different types of actuators which are available for driving the control valve or for closing and opening the control valve. So the first type is spring and diaphragm. Next is piston cylinder. In this we have two types. So piston cylinder comes in pneumatic as well as hydraulic. Then we have a combination of electrical and hydraulic actuator. Next is electrical. In that we have two types, solenoid and motorized. Now we have so many options that are available for the type of actuator which is used for opening and closing the control valve, and how to make a selection. Now selection depends upon what is the availability of the operating medium. We have three types of systems: electrical systems, pneumatic systems and hydraulic systems. So for these three systems, signals, for electrical systems we have current signals. Then for pneumatic systems you have compressed air as the medium, and for hydraulic systems we have pressurized oil. So whatever operating medium is available, accordingly we can make a selection. Then fail-safe requirement. In case of spring and diaphragm, it is inbuilt. Fail-safe action is inbuilt. So if the air fails, the valve either closes or opens due to the spring. Then actuator capability means how much force the actuator is capable of generating. Hydraulic actuator will generate the highest force. Then environmental conditions, that is if the atmosphere contains explosive gases, then pneumatic actuator is the safest. And if you look at the economics, then the cheapest one is the spring and diaphragm type of actuator. So these are the selection criteria for the type of actuator. Now let us see the features of these actuators one by one. Spring and diaphragm, already we have seen the construction when we saw parts of a pneumatic control valve. So in this actuator there are parts, two main parts, that is diaphragm, which is sensing the compressed air. Then there is a diaphragm plate which is concentric with this diaphragm. Then we have a rod-like extension of the diaphragm plate, that is the valve stem, and a spring. Now diaphragm will have upper surface and lower surface. If compressed air is applied on the upper surface, spring is on the lower surface of the diaphragm. Now if you see the advantages, in most of the control valves, this is the actuator that is used. Simple, because minimum number of components are required, and if you look at the parts, spring and diaphragm, they don't get damaged, so maintenance is less, it is cheap. Then being compressed air, as the medium, it is safe in hazardous area. And due to the spring, it has got inbuilt fail-safe action. We need not have any extra in the actuator. By virtue of its construction, it provides this fail-safe action. Disadvantage is that the force that is generated is limited, so it doesn't give faster response. And in case if you want to have larger forces, then the size of the diaphragm goes on increasing. Now next type of actuator is piston cylinder, which can be either pneumatic or hydraulic. So this is the cylinder, and inside the cylinder we have the piston. The rod of the piston is the valve stem, and this part is the actuator, and this bracket which is seen is the yoke. So using this yoke, this piston cylinder, that is the actuator, is mounted on the valve body. So just below this yoke we will have the valve body, inside which we will have the plug and the valve seat, which is responsible for changing the flow. And the rod of the piston will be connected to the plug. Okay. So as this piston reciprocates inside the cylinder, the valve is going to open and close. So if you want to say extend the piston, compressed air will be given to the cap end, and the air at the rod end will be exhausted. If you want to retract the piston, then air will be given to the rod end and compressed air at the cap end will be exhausted. Now let us see the advantages and limitations of piston cylinder type of actuator. Normally piston cylinder type of actuators are used with valve positioners. Now valve positioners basically ensure that the valve is correctly positioned as per the input signal. So later we will be seeing what is valve positioner. So since this type of actuator is using valve positioner, it will give exact positioning. The force that is generated is much faster as or more as in comparison to spring diaphragm, so that will gives us faster response. If it is pneumatic, it is safe in hazardous area, and the forces that are generated are much higher in case of piston cylinder in comparison with spring diaphragm. Now what are the limitations? Now since we have to drive the piston inside the cylinder, the air pressure which is required is sufficiently large, then definitely it is more expensive than spring and diaphragm type of actuator, and it doesn't have inbuilt fail-safe action. Now next type of actuator is electro-hydraulic actuator. So it is a combination of two systems. Input is electrical, that is 4 to 20, and the actuator which is driving the valve is piston cylinder, which is driven by oil. So it's a combination. It consists of, this is the piston cylinder, and this is the yoke. Using this yoke, we are fixing this piston cylinder onto the valve body. So inside this valve body, we will have the plug and the seat. Okay. Now this piston cylinder has got two ports. This is the upper port and this is the lower port. Okay, where we will be giving the oil, pressurized oil. Now this jet pipe is giving oil to both the ports of this cylinder. Okay. Now if you look at the position of this jet pipe, it is exactly vertical and it is pivoted at the center. This end of the jet pipe is having a coil through which the input signal is going to pass, that is 4 to 20 milliamperes. Now this coil is surrounded by a E-shaped magnet. Now when the jet pipe is exactly at the center, or you can say center of these two ports or vertical, equal amount of oil is going to both the ports of this piston. That is why there is no movement of this piston. Now if you pass current through this coil, then this coil will experience a force because current carrying coil is placed in the magnetic field. So there will be some force. Now the current direction through this coil will be such that the force that is experienced is towards such that it will move towards the magnet, as shown by this red arrow. So this part of the jet pipe is attracted towards the E-shaped magnet. So this part of the jet pipe will move towards the right because this end is moving to the left. There is a pivot at the center. So this jet pipe will be aligned more to this port, that is the upper port. So more amount of oil will go to the upper port than to the lower port. So that will cause the piston to be pushed in the downward direction. Now when the valve gets positioned according to what current is passing through this, there is a feedback that is taken of the valve position. As I told you, piston cylinder type of actuators are normally used with valve positioners. So they take a feedback of the valve position. So when the piston goes to the required position, the jet pipe comes to the original position, that is a vertical position. So once the valve is correctly positioned, the jet pipe becomes vertical, equal amount of oil goes to upper port as well as lower port, and the valve stops moving. So this is the feedback link which is not shown in this figure. So this is the feedback link which is bringing the jet pipe back to original position when the valve gets to the required position. Now let us see the advantages. Develops maximum power because hydraulic system is used. Accurate positioning because we are taking the feedback of the valve position and accordingly we are adjusting the position of the jet pipe. Now the power that is generated is highest, so definitely faster response is possible in this type of actuator. Now what are the limitations? Since the medium is oil, it is not safe in hazardous area. For the same reason it is expensive and lot of maintenance is required if it is oil, and cleanliness is required because the piping system should be cleaned regularly. Now next we have electrical actuators. In that we have solenoid actuator. This is the coil of the solenoid. This is the movable core which is connected to the valve stem and the plug. Now in this figure we can see the plug which is sitting into the seat. So it is closed. So this fluid at the inlet cannot go to the outlet. Now when this coil is energized, then there is a magnetic field which is generated which will pull this movable core towards itself. So this movable core will move up. That will cause this stem and this plug to move up. So that will cause the valve to open. Thereby the fluid at the inlet can go to the outlet. What are the advantages of electrical? So in remote locations where it is difficult to carry air and gas, then we can go for electrical actuators. But disadvantages that it gives slow response because the force generated is less, more expensive, and it is not used in hazardous area because there can be sparking and the atmosphere can catch fire. Now this is motorized type of actuator where the motor is driving the stem, and here also we have two potentiometers. One potentiometer is giving voltage which is corresponding to the required valve position, and feedback potentiometer will give a voltage signal which is corresponding to the actual stem position. So this is the set point and this is the measured value. So if there is any difference between these two, that difference will be amplified by this differential amplifier and given to the motor. Now motor speed is quite large. So to reduce the speed of the motor, we have a gear train, and also we have to convert the rotary motion of this motor to linear motion of the stem. So we have two meshed teeth over here. So as this part rotates, okay, the teeth on this part is meshed with the teeth on the valve stem. So as this part rotates, this is going to move in a linear fashion, that is in the vertical direction, up and down. So when this stem goes to the required position, this voltage and this voltage will be same. So input to this differential amplifier will be same, and the motor will stop and the valve